When we see AI understand language, it feels like magic. But a huge part of that magic comes down to a choice between two math functions. One of them, Softmax, is the secret sauce behind an AI's ability to focus. But the other, a function called Sigmoid that looks almost identical, just doesn't work for this at all. So today, we're going to figure out why.
So let's just jump right in. Imagine an AI is reading a sentence. To get the meaning, it can't just treat every word equally. It has to figure out which words are the most important. Is it the main verb? Is it a key noun? It has to make a decision about where to spend its, very limited brain power. How does it do that?
And here's the absolute key to understanding this. It's not about giving each word its own independent score. It's a competition, a battle for importance. If one word gets more attention, other words have to get less. It's basically a zero-sum game for the AI's focus. A great way to think about this is like a spotlight. The AI has one spotlight, which is 100% of its focus. It has to shine that one beam of light across all the words in the sentence. It can't just make the light bigger. It can only decide how to divide it up. So the whole job of what we call an attention mechanism is to assign a number, or a weight, to every single word. That weight tells you how much of the spotlight is shining on that word. A high weight means the AI is laser focused, and a low weight means it's pretty much in the dark. All right, so any math function that wants to be in charge of this spotlight has to play by three really strict, non-negotiable rules. These are the tests, and they're going to be what separates our hero function from the one that just can't cut it.
Okay, rule number 1, all the weights have to be 0 or more. You can't have negative importance, right? Rule 2, and this is the big one, all the weights for all the words have to add up to exactly 1. That's 100% of the spotlight, no more, no less. And rule 3, the function has to create competition. It has to understand that giving more attention to one word means you're automatically taking it away from the others.
So let's bring in our first suspect, the sigmoid function. Now, on the surface, this function looks like a pretty good candidate. It's used everywhere else in machine learning, so why not here? Well, let's put it on trial and see how it holds up against our three rules. The sigmoid function is really famous for one thing. It can take any number you throw at it, big, small, positive, negative, and it squishes it down into a nice, tidy value somewhere between 0 and 1. And that sounds perfect. It passes rule number 1, being non-negative, without even breaking a sweat. So far, so good, right? Well, this is where the whole thing just falls apart. When you apply sigmoid to all the words in a sentence, and then you add up those weights, they almost never, ever equal 1. So our spotlight is totally broken. Sometimes it's spilling light everywhere, sometimes it's barely on. Sigmoid completely fails that critical sum to 1 rule.
And because of that one failure, you get this whole cascade of other problems. The AI's internal numbers can just grow and grow uncontrollably as sentences get longer. That's the scale explosion. It also totally violates rule number 3 because it looks at each word in a vacuum. There's no competition, no sense of how important one word is compared to the others. So the weights it creates, they don't really mean anything in a probabilistic sense. It's just a total mess.
And now, let's bring in our hero, the Softmax function. This thing was practically born to solve the exact problems that Sigmoid couldn't even touch. Let's see how it handles our little test. The absolute genius of Softmax is right there in the formula. Look at the bottom part, the denominator, that big sigma symbol. It calculates a score for each word. But then, and this is the game changer, it divides that score by the sum of all the scores from all the words. That one simple step makes all the difference. Because of that division step, the final weights are mathematically guaranteed to add up to exactly 1 every single time. Our spotlight is perfectly calibrated. Softmax just aces rule number 2, creating what we call a true probability distribution. And this really shows the core difference. Using Sigmoid is like having a separate dimmer switch for every single word. You can turn one up all the way and it doesn't affect the others at all. But Softmax is one shared spotlight. If you want to make it brighter on one word, you have to steal that light from all the other words. It forces that global competition that we need for rule number 3. So why are we so obsessed with the weights summing to 1? It's not just about being mathematically neat and tidy. This one property unlocks something incredibly powerful and stabilizing for the entire AI model. Because the softmax weights create a perfect probability distribution, the final output of the attention mechanism actually becomes a weighted average. In statistics, this is called an expectation. It means the output is a sensible, meaningful blend of all the words, weighted by just how important they are. And the real-world benefit of this is huge. Since the output is just a weighted average, it's guaranteed to stay within a predictable range. It can't spiral out of control. This completely prevents that dangerous scale explosion we were worried about with Sigmoid. It keeps the AI stable and behaving itself.
Okay, let's bring it all home. We've seen the evidence, we've run the tests. It is time for the final verdict. Let's nail down the one core difference between these two functions.
And here it is, the final scorecard. It is a total clean sweep. Softmax is normalized, it's probabilistic, it creates competition, it gives you stable scaling, and it understands global context. Sigmoid? It fails on every single one of these things that are absolutely essential for an attention mechanism. The choice really couldn't be any clearer.
So if you take one thing away, let it be this. Softmax forces the AI to make a choice. It turns a bunch of raw scores into a competitive, probabilistic focus. Sigmoid, on the other hand, just creates independent activation. It tells you if a word is interesting on its own, but it doesn't tell you how interesting it is compared to everything else. And when it comes to AI attention, what's the point of a spotlight if it can't decide where to shine?